Okay, calculus kids, this is take 2. I messed up on the other one, so let's see how this one goes. Hey, here's what you're going to be missing on Tuesday, whether it's for the musical or the blood drive or seeing your great aunt Sally, whatever the reason is. What I'm going to do is I'm going to field any questions over section 3.3 for the people. And then what I'm going to do is there's an optional skill check on here for you. Use that if you would like, but it's optional. But what I did for you, it's what your quiz looks like. So let me get some ink color here that I like. So there's a skill check on there. Then I'm going to cover section 3.4, which is very, very similar to what we did last time. And your assignment is going to be on the last slide of this, but it's out of the book. But here's the optional skill check. It's what your quiz will look like. These are questions out of 3.1, and these are questions out of 3.2. So you can pause the video and do that. There are your answers so that you can even check them. And then if any of them that you think you'll get stuck on, there's my work on them. I will point out on number 4, because some of you had problems on this. After I factored out number 4, I can remove this x plus 2 part. That means there's a hole in the graph at x equal -2. If there's a hole in the graph, then there's a limit. Limit and hole equal the same thing. And then I got the limit to be 7/4 by plugging in -2. But use that how you will. I'd like to get your quiz caught up either Tuesday morning, Tuesday after school, or Wednesday morning. I'm here by 7:15. I can come in earlier if you need me to be here earlier. But here's our lesson today. What I'd like to do is, given f of x equal 2x squared minus 8x plus 12, I'd like to find the instantaneous rate of change at these 5 numbers. We did this last time, but think about this. For you to find the instantaneous rate of change at x equal -2, here's what you would have to do. The limit as h approaches 0 of f of -2 plus h minus f of -2 all over h. And then remember, we plug that up into there. And then after you get that one done, you would have to come back and do it again. The limit as h approaches 0 of f of 0 plus h minus f of 0 all over h. And then after you get all that work done, you'd have to do it another time, and another time. So this would really be 5 problems at once. And Lord knows we don't want to do that. So here's what I'm going to do with you today. I'm going to show you a way so that we come up with a formula. The function, this formula right here, the limit as h approaches 0 of f of a plus h minus f of a all over h. This tells us the instantaneous rate of change at some point. What I want to do is come up with the formula today that'll find it at any point that you would want. So here's what it's going to look like. Here's what we did last time. This is the formula that we used last time right there. F of a plus h minus f of a all over h. In this case, a is a certain point. All I'm going to do to you today, and it's just a bunch of algebra, is I'm going to change the formula to this. Look the 2 formulas over. My a really becomes an x. X for any point that you would want to work with. A is a certain point, 2, 3, 5, -10. X is any point that you want. Then we will come up with a formula. Then I could plug in all the values in the world that I want. So I am going to click through the algebra because 1, you're smart. 2, I don't want this video to be too long and bore you more than it probably already will. So here's what it's going to look like. Find each of the following derivatives. And physics people, you're going to hate this statement. You still got to show me all the algebra. Even though you got a little cheesy rule, that rule doesn't always work with what you have. So hang with me on this. But here's what you're going to do. To find this limit, to find a formula that will find me the derivative, the instantaneous rate of change, I need to do this. The limit as h approaches 0 of f of x plus h minus f of x all over h. Last time it was an a, this time it's an x. So this really becomes x plus h quantity squared minus f of x, which in this case is x squared, so I'm going to get rid of that, all over h. And that's going to be our limit as h approaches 0. Then it's just algebra time, guys. I got the limit as h approaches 0 of x squared plus 2xh plus h squared minus x squared all over h. When I simplify, my x squareds are out of there. So I'm going to be left with the limit as h approaches 0. I'm going to divide out my h, so I've got 2x plus h. Let h go to 0, so 2x is the formula that will give me the instantaneous rate of change. Notation is big. You don't do your notation for me, I dock you pretty big. Here's what the notation looks like. F prime of x then equals 2x. What does that really mean? The slope of the tangent line of x squared can be found by the formula 2x. And then if I wanted you to find the slope at a certain place, you just plug in that. So I could ask you now, hey, go find me f prime of 2. That's saying, hey, go tell me the slope when x equaled 2. You'd plug 2 right there and tell me it's 4. But that's what we're going to do. It's the exact same thing that we did last time. This time there's just a bunch of algebra in there. So hang with me. It's going to look like this on the next one. Once again, guys, we're going to find the limit as h approaches 0 of f of x plus h minus f of x all over h. If I had a stamp, I would just stamp that formula every time. So here's what it looks like. The limit as h approaches 0 of 2 times x plus h squared minus 3 times x plus h plus 5. That takes care of that part, the x plus h part, but I've also got minus 2x squared plus 3x minus 5, and then all of this is over h. And then I'm going to click through the algebra part. I'm going to quantity square that, and then I'm going to distribute. So I would see something that looks like this. 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 5 minus 2x squared plus 3x minus 5. All of that's over h. If you've done a good job to this point, if it doesn't have an h in it, it should cancel out. So that and that, that and that, that and that are all out of there. Now I'm going to take out a h out of each term that remains, so I've got 4x plus 2h minus 3. So that's what I've got so far. So let h go to 0. Here's what I get then. F prime of x is 4x minus 3. What you just did is you found a formula that will give you the instantaneous rate of change at any point on this parabola. Now if I said, hey, go tell me the slope at 5, you're just plugging 5 into there. 20 minus 3 is 17. The slope of the tangent line at x equals 5 on this parabola is 17. That's going to be the gist of our lesson. All I'm going to do is try to get you familiar with it. Hey, here's a hard one. 2x cubed plus 4x. We're going to find the formula. Then I'm going to find the slope of the tangent line at 2 and negative 3. So here's what we got, guys. The limit as h approaches 0 of f of x plus h. So I'm going to go 2 times x plus h cubed plus 4 times x plus h minus f of x minus 2x cubed minus 4x all over h. Hey, we did one of these in class the other day, but here it goes again. To do this cubic right here, I'm going to use my good friend Pascal's triangle. And I'm going to go to there. It's a shortcut for multiplying out a binomial. These are the coefficients if it's to the 0 power. These are the coefficients if I take x plus h to the first. These are the coefficients if I take x plus h to the second. These are the coefficients if I take it to the third power. So here's what it's going to look like. I'm not even going to distribute that 2 through so I don't confuse you. I'm going to have 2 times. To do the x plus h cubed, I know I'm going to have an x cubed. My next term is going to have a 3 in it. My x goes down by 1. My h goes up by 1. My next term is going to have a 3 in there. X goes down by 1. H goes up by 1. And then my last term is a h cubed. All I've done so far, guys, is that right there. I still have plus 4x plus 4h minus 2x cubed minus 4x. All of this still over h. And then I'm going to distribute some more. I'm going to distribute that 2 in there. So I've got 2x cubed plus 6x squared h plus 6xh squared plus 2h cubed plus 4x plus 4h minus 2x cubed minus 4x all over h. Then again, if it doesn't have an h in it and you've done a good job, things are going to cancel. That and that will cancel out. 4x and negative 4x will cancel out. Now I'm going to take a h out of my remaining terms. So I've got 6x squared plus 6xh right there plus 2h squared for right there plus 4h over h, and then everything else cancels out. When I let h go to 0, that's out of there and that's out of there. So I've got this. F prime of x is 6x squared plus 4. Okay? Yes, physics people, you would have to show me all of that work. Keep in mind, I love you. Now, if I want the slope of the tangent line at 2, I'm just going to run 2 through there. And I think I get 28. The slope of the tangent line at negative 3, I'm going to run negative 3 through there, and hopefully it's 58. I'm trying to hurry, so if I make a mistake, you can catch me on it later. But there's that one. Here's another one. Physics people, here's where your little rule messes you up. F of x is 5 over x. Find f prime of x. So once again, I'm going to do this. The limit as h approaches 0 of f of x plus h minus f of x all over h. It looks like this. I have a limit as h approaches 0 of 5 over x plus h, I sub that in right there, minus 5 over x. All of this is over h. Okay? Hey, I'm going to do just like I did in class. I'm not going to worry about this h until the very end. So I'm going to save that h for a little bit. I'm going to concentrate on that 5 over x plus h minus 5 over x. I know that some of you already know where I'm going to go with this. It's a fraction. Common sense says with the fraction, we're going to have to get a common denominator. My common denominator is going to be a x times an x plus h. X times an x plus h. To go from this denominator to this denominator, I'm missing the x, so I got 5x. And to go from this x to this x times x plus h, I'm missing the x plus h, so I got minus 5 times x plus h. Remember, I haven't done anything with that h yet. So this really becomes 5x minus 5x minus 5h all over x times x plus h. When I simplify this, it looks like I'm going to get negative 5h over x times x plus h. And I'm missing something somewhere because I got in a hurry. So I got negative 5 over... Oh, no I haven't. I forgot about that h I hadn't let come out to play yet. Hey, finally guys, at this point, I'm at negative 5h over x times x plus h. Now I'm finally going to let this divided by h come out. So I'm going to treat that as times 1 over h. Now watch what will happen. These h's will cancel out, leaving me negative 5 over x times x plus h. Now when I let h go to 0, I'm going to get negative 5 over x squared. Okay, so here's what I got. I got that f prime of x is negative 5 over x squared. So there's what we got on that one. Don't forget, like I almost did, I almost forgot to use this guy. Here's my next example. Here comes a radical. Remember in class the other day when we had a radical, we had to use the conjugate? The same thing applies here. We're going to try to find the limit as h approaches 0 of f of x plus h minus f of x all over h. So I'm going to get this. I'm going to get 3 times radical x plus h minus 3 radical x all over h. Okay, I just sub that in. When this radical shows up, I have to multiply by the conjugate. The conjugate of this is going to be 3 times radical x plus h plus 3 radical x over that same thing. So there's the conjugate. This thing gets ugly now. So hang with me with the algebra. This really becomes the limit as h approaches 0. I'm going to FOIL out the top. So I'm going to go here to here. So I'm going to take 3 radical x plus h times 3 radical x plus h, and I'm going to get 9 times x plus h. And then the middle terms are going to drop out, minus 9x all over that whole denominator. So you'll see what happens with it here in just a second. But I got h times 3 radical x plus h plus 3 radical x. This becomes 9x plus 9h minus 9x. So I'm going to get 9h over h times 3 radical x plus h plus 3 radical x. Man. But now watch what happens. These h's cancel out. So my numerator, the limit as h approaches 0, my numerator becomes 9. When I let h go to 0, I'm going to get 3 radical x plus 3 radical x, which is 9 over 6 radical x, which is 3 over 2 radical x. Hey, some great news finally. It's okay in Calc to leave that radical. That is cool. We'll see that a lot. So f prime of x is going to be 3 over 2 radical x. This worries me. It's kind of spinning. To find f prime of 4, just plug in my 4. So I'm going to get 3 over, square root of 4 is 2. 2 times 2 is 4. To find f prime of 16, same thing. Plug in a 16. Square root of 16 is 4. 4 times 2 is 8. So that slope would be 3/8. Okay. So that's what we've got so far. Here's another one just like it. I can fly through it for you if you want. Otherwise, you could always hit fast forward. But it's going to look like this. The limit as h approaches 0 of 7 times x plus h minus 7 radical x all over h. I'm going to multiply by the conjugate, which is 7 radical x plus h plus 7 radical x over itself. That way I'm multiplying by a number equal to 1, which doesn't change anything. My numerator becomes 49x plus h minus 49x, which really becomes 49h over h times 7x plus h plus 7 radical x. These cancel out. So then I've got the limit as h approaches 0 of 49 over 7 radical x plus h plus 7 radical x. Let h go to 0, so I've got 49 over 7 radical x plus 7 radical x, which is 14 radical x. So it looks like in this case it's going to be 7 over 2 radical x. Okay? So notation, you got to write this for me. F prime of x is 7 over 2 radical x. I'm not going to waste your time and find f prime of 16, because you can use your calculator and do that for me. But there's what we got so far. And I'm getting close to done, believe it or not. I'm getting close to done. Here's another one. I'm just going to take it a step further. Let f of x be 2x squared minus 3x plus 1. And then I would like to find f prime of x. And then write the equation of the tangent line at x equal 3. The equation of the tangent line. When we use this formula right here, the limit as h approaches 0, that you've seen me write 100 times now, it seems. This really gives you the slope. It gives you the slope of the tangent line. So now we're just a different way to find slope. So here's what I've got real fast, guys. I've got the limit as h approaches 0 of 2 times x plus h quantity squared minus 3 times x plus h plus 1 minus 2x squared plus 3x minus 1. Notice I distributed my negative sign. All over h. And then super fast, this becomes 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 1 minus 2x squared plus 3x minus 1 all over h. That and that are out of there. That and that are out of there. That and that are out of there. Divide everything by h, so I'm left with the 4x. Don't need an equal sign there. I've got a 4x plus 2h minus 3. So here's what I got. F prime of x, the equation that will tell me the slope of the tangent line at any point that I want to work with, is 4x minus 3. That's what I've got so far. But now, here's what I'm going to do. I'm going to find f prime of 3. 4 times 3 is 12. 12 minus 3 is 9. So what did I just really find? I found my slope. I found my slope. Now I need to write the equation of a line that has a slope of 9 and an x value of 3. Well, here's what I'm going to do. If my x value is 3, I'm going to plug 3 into this equation to get my corresponding y value of 10. Now I need my b value, so I'm going to go y equal mx plus b. I'm going to go 10 equal my m value, which was 9, times my x value of 3, plus b. So b is going to be negative 17. So guys, it's just another way to find slope. So my equation of the tangent line, y equal 9x minus 17. So really, what are you doing? You're finding slope another way. You're finding slope another way. I will show you in a second how to check this, but I'm going to make sure my PowerPoint works. I want to show you a couple things. I'm going to come back to that. Okay? Just some little quick things. You can see this in the book, but the derivative exists for a function when all of these conditions are defined. It's got to be continuous. So this means no jumps, no breaks, no holes. If there's a jump or a hole there, there's not a derivative at that point. There's not a rate of change at that point. It's got to be smooth. It means it can't have any sharp points to it. And then there's no vertical tangent lines. And I'll show you an example of that here. The derivative does not exist when any of these happen. Discontinuous. You can't draw it without picking up your pencil. If it has a sharp corner, right there, has a vertical tangent line. So here's my little slide here, just to kind of show you on some different points. There's no derivative. There's no instantaneous rate of change. There's no tangent line at this point and this point because of the sharpness of it. My tangent line would almost have to teeter-totter on that. There's no derivative here because there's a jump. The limit isn't defined as I approach that 3 value. There's no derivative here because of that vertical asymptote. And there's no derivative here because of that vertical line that could be drawn. And there's no derivative there because of the hole. Okay? So I've got a few problems on there. I've got one more thing to show you because you can check these on your calculator. I'm going to show you that. But there's going to be your assignment. notice I gave you the odds. You can check them in the book. I'm going to show you how to check them on your calculator also. And then 33 through 36 all is matching. But I'm going to show you the calculator, and I'm doing this last in case this freezes up. But let me go into my calculator. And it says, is there a way to check this? Here's what I did. The last example that we did, that 2x squared minus 3x plus 1, where we got the slope to be 9, here's what I did, guys. I graphed it. So I hit graph. I'm wondering if that 9 is right, the rate of change, the slope of the tangent line. So I'm going to go second calculate, and I'm going to go down to number 6. dy dx is another notation for derivative. So I'm going to hit enter. And it's going to say, hey, where do you want me to tell you the answer at? Tell it 9. Oh, wait a minute. Tell it 3. 9 was our answer a while ago. We wanted the slope of the tangent line at 3. I'm going to hit enter. It's going to tell you the slope is 9. And that's what we come up with just a few seconds ago. So you can check it. Of course, why am I doing an assignment out of the book? Because I want to see your work this time. So there's what we got. Then like I said, guys, there's your assignment. 5 to 23, the odds, 33 through 36, all of them. And like I said, most of them are in the back of the book. Good luck, and then get in and get your quiz taken care of ASAP. Give yourself probably about 30 minutes on that quiz just in case. Good luck.